and 1 external fuel tank. Over a 10-year span, 5 orbiters were built, including the test vehicle named Enterprise, and the 4 space orbiters, Columbia, Discovery, Atlantis, and Challenger. On April 12, 1981, after years of testing and construction, the first shuttle, Columbia, reached orbit piloted by astronauts John Young and Robert Crippen. The first 4 shuttle flights were collectively called the Orbital Flight Test Program and demonstrated how the spacecraft performed under real spaceflight conditions. During these first 4 flights, NASA tested the shuttle as a launch vehicle, habitat for crew members, freight handler, instrument platform, and aircraft. After the 4th landing, NASA declared the shuttle ready for operation. Since that time, the shuttle program has performed well over 100 missions and has accomplished a number of monumental achievements. In June 1983, Sally Ride became the first American woman in space. The shuttle launched the Magellan spacecraft to Venus, the Galileo spacecraft to Jupiter, and the Ulysses spacecraft to study the Sun. The shuttle also has deployed the Hubble Space Telescope, the Gamma Ray Observatory, and the Upper Atmosphere Research Satellite. Another key milestone came in 1998 when astronaut John Glenn, the first American to orbit the Earth, returned as the oldest man ever to reach space as a member of the crew of Discovery on a 9-day mission. The shuttle has also been instrumental in constructing and outfitting the International Space Station, while also being used to carry large payloads to and from orbit and perform servicing missions on satellites. The design, now approaching its 3rd decade, is still state-of-the-art in many areas, including computerized flight control, airframe design, electrical power systems, thermal protection system, and main engines. Even though the sophisticated shuttle program suffered the devastating losses of the Columbia and the Challenger, its successful missions have made great strides in space travel and exploration during its short history. More than 100 documented NASA technologies from the space shuttle are now incorporated into the tools we use, the foods we eat, and the biotechnology and medicines used to improve health. Although plans are now in the works to retire the fleet, the Space Shuttle program will forever hold a special place in the history of space travel, not only for its unique design, but for the history and technologies it brought to all of us.
The Space Shuttle has been one of the most valuable and important tools in our quest to increase our understanding of space. It is scheduled to go out of service in the near future, being replaced by the new Crew Exploration Vehicle. Up next, we'll find out exactly how sonic booms work. But first, did you know Enterprise, the first space shuttle test vehicle, was originally to be named Constitution in honor of the U.S. Constitution's bicentennial? However, viewers of the popular TV science fiction show Star Trek started a write-in campaign urging the White House to change the name to Enterprise. Designated OV-101, the newly named Enterprise was rolled out of the assembly facility on September 17, 1976 to begin its work as a flying test bed. Although it never flew in space, the Enterprise flew 8 captive flights attached to the 747 shuttle carrier and 5 free flights that landed at Edwards Air Force Base. The Enterprise was enormously successful helping test and prove technologies that would be needed in future space shuttles. In November 2003, Enterprise was moved to the Smithsonian Stephen F. Udvar-Hazy Center near Washington Dulles Airport, where it is now on permanent public display. Today in our busy world, one of the key prerequisites for many people in personal and business life is speed. This is especially true when it comes to aviation. Although air travel is almost always the fastest means of travel, many would like it to become even faster. Though the technology exists for aircraft to fly at speeds faster than the speed of sound, today's aircraft don't because of the problem with sonic booms. To help lessen the impact of these booms, NASA researchers are attempting to find a way to help aircraft move faster without causing disruptions on the ground. Our own Johnny Alonso spoke with researcher Dr. Kevin Shepard at NASA Langley Research Center to learn what a sonic boom is and find out how it works.
In the early days of flight, having an